Hey ladies, so today we're working on section 5.2, which is transformations of sinusoidal functions. So just to start off, so we can translate. We can translate graphs of functions either up or down, we can move them left or right, and we can also stretch them vertically and also horizontally. So the rules that you guys know through previous functions, you should know this from previous classes, and I think you guys did this earlier. So those same rules apply to the curves that we're going to be looking at today. So our first translation that we can do on a sinusoidal curve is a vertical displacement. And the vertical displacement is, it's a translation of the graph of a periodic function. So it'll move your graph up and down. And if you recall, we do have our standard, I guess, functions for sine and cos. So here we have y is equal to some constant a times the sine of some constant b multiplied by theta, subtract some constant c plus d. So this kind of looks like just the normal, I guess, equations that you've been looking at earlier. Just this time we're dealing with the sine. Alright, and we also have one for the cosine. We have y is equal to a times cos of some constant b, multiply that with your theta, subtract c, and that is plus d. And so with vertical displacement, what we're really looking here at is your value d. So if your d is greater than 0, the function shifts d units up. Obviously, if it's at 0, it's not going to shift up or down or at all. It's just going to stay where it is. And if d is less than 0, the function will shift d number of units down. And there is an equation. If you don't have the graph, if you just look at the equation, we do have a little formula for to find the vertical displacement. And that is that d is equal to your maximum plus your minimum, and that is all divided by 2. So that looks really close to your amplitude, except the difference here that we're adding the minimum and the maximum value, whereas before we were subtracting the 2. Okay, and so our next translation is, we have what we call phase shift. And this is the horizontal translation of the graph of a periodic function. So here basically what we're looking at is it moving to the left or to the right? And so this will be determined if this is by the value c going up to these equations that we kind of set for a general form of cosine and sine. So we're looking at the c value here. So if your c value is greater than 0, the function shifts c units to the right, and if it's less than 0, so if it's negative, the function will shift c units to the left. Alright, and if I could just point out also, just remember that in your equations you're going to have negative c, so don't forget that you'll have to take the positive value of that, or I guess it'd be the opposite value. Okay, so now we're going to do some examples. I'm not sure what happened there. We'll just put that one back down there. Alright, so in this example we're going to sketch the graph of y is equal to the sine of theta plus pi over 2. That's all adding to 3. And here we need to state the domain and the range. So similar, just like the last lesson, you're going to pause the video, try calculating a few values on your own, and then you can use your graphing technology to sketch your graph. So just make sure you pause the video, and what will be, I guess in a couple seconds, I will put all my work on there, and we'll also see the graph there and kind of have a chit chat about that. So make sure you pause the video, and we'll see you in a bit. Alright ladies, hope you had a chance to work this out for yourself. So just as a key point, if you want to just point out some key points from your table of values here. When theta is equal to 0, your y value should be equal to 4. When it's pi over 2, your y value should be 3, and when theta is equal to pi, your y value here should be 2. So there's just a quick go over. Hopefully you had some time to look at this for yourself. Definitely make sure you try plugging in a few of these values into your calculator and solving. That way you have that practice, and then you can get the rest of your table values through using your graphing calculator. Alright, and so now looking onto our graph, you see that this is our graph of our sine curve. Hopefully yours will look something like this. So just some key points. If we were to look at our c value here, just remember that it is the negative value, so this is actually, your c is equal to negative pi over 2. So if we were to go there, which is approximately somewhere over here, you notice that this is where your sine, your graph of sine should have started, because if you remember, your standard position of sine should be, it should be starting at really your origin, or at your y-axis. So you'll notice that you're actually the middle, or the beginning of your sine graph will be starting at negative pi over 2. And then so kind of go along with that whole relationship there, and we'll just keep going. So the only difference here that the c value here has moved it, has shifted it to the left by pi over 2. So next thing that we can look at here is our phase shift, and that was here, it was positive 3. So if you notice, if you were to go back to your original starting position, it should have started at your, it should have started at 0, 0, or it should have started at this y is equal to 0. But if you notice, that value has actually gone up, so now we're going to be starting at 3 instead of at 0. So there's a quick look at that. One thing that, actually I'm going to go to our graphing calculator, and we'll actually see how these values here will actually affect your sine graph. Alright, so here is the online graphing calculator. I just used the one from Desmos.com. You guys can Google it if you don't ever have your graphing calculator with you. But here I've graphed y is equal to sine of x. So if we were to graph y is equal to the sine of x plus 3, this is with that phase shift. This here is where you're going to notice it moved up by 3 units. So now what we can look at, so there's an idea of what the phase shift is like. So now we can look at the vertical displacement. So we're going to put x, and we're going to go plus bracket pi divided by 2. And here you'll notice that it actually shifted your graph negative pi over 2 to the, or I guess it'd just be moving it pi over 2 to the left. So there's also that to look at, and if you want to see it all together, we'll add 3 in there, and that is exactly what it's going to look like. So there's a little snapshot view of what vertical displacement and phase shift will do. So there we are. So we'll move on to the next example. So example 2 says to write 2 sinusoidal equations of the form y is equal to a sine of b times theta minus c plus d, and y is equal to a cos b multiplied by theta minus c and adding to with d. And this we'll do this to present the function shown in the graph below, and then we can verify our solutions using our graphing technology. So we're going to be dealing with, we'll start off with y is equal to a sine b theta minus c plus d. We're going to start off with that. So first of all, what we're going to try and find is, we're going to find a, b, c, and d. If you guys remember, our a value is our amplitude, and that is equal to your max minus your min, and that is all divided by 2. So looking here at this equation, your maximum there, this looks like it'd be 1. Your minimum here is at negative 3 minus negative 3, and that is all going to be divided by 2. And when you solve that out, we should get your amplitude is equal to 4 over 2, or just simply 2. To find our value of b, and if you recall, that is your period, math period, ... that is equal to 2 pi divided by the absolute value of b. So if you know what your period is, then you can solve for b. So here, what we can take a look from here is our period. So it'll start here, and we're going to go all the way across until we get back to here. And so if you look from 0 to 2 pi over 3, that's going to be your distance of your period. So that is 2 pi divided by 3, and that is going to be equal to 2 pi divided by the absolute value of b, or for now we can just write b. We'll just assume that it's a positive. So then to solve, you guys can use whatever method you use, but I would typically, with 2 fractions, I cross multiply and divide, and what you ladies should end up with is that your b value there is 3. And then if you want to check that out, try putting that back into that equation. So you have 2 pi divided by the absolute value of b, you get 2 pi over 3, which is your period. So that's awesome. All right. So our next one we need to find is our c value. So your c value is your phase shift, and so that's whether or not it moves, your graph moves to the left or to the right. So if we're looking here at a graph, it should be starting along x is equal to 0, And if you notice that our little midpoint there, which is typically where our sine graph starts here, it is shifted to the right by pi over 3. So that there will be your value there. So it's c is equal to pi divided by 3. So just remember, it is by how much your graph has shifted to the left or to the right, and here in this case it has moved to the right by pi over 3. Our next one, to find d, that is equal to your maximum plus your minimum, and that is all divided by 2. And similarly, so we have 1, and this is going to be plus a negative 3, and that's all divided by 2, which is equal to negative 2 over 2, which is simply just negative 1. Wonderful. So when we put this all together, we should have that y is equal to, your a value there was 2, that is multiplied by sine, your b value there was 3, and you have theta, subtract your c value, which was pi over 3. Close your bracket there, and your phase shift there, your vertical displacement there was negative 1, and then you're done. So next one we can do is our cosine. Ladies, if you want to try pausing this, try doing the cosine on your own. Just remember that cosine usually starts up at, your value usually starts at 1, so it would be over here. And I typically try and go with the closest one, so we don't want to use a super far value. I'll typically use where it would start off the closest. Alright, so when you're dealing with cos, one really nice little bit of information is that if you calculated some of this before, you do not have to do it again. If you notice that your max and min, they have not changed whatsoever. We're dealing with the exact same graph, so we don't need to go back and find A, we don't need to go back and find D, we already did that work. And this also applies to B. The period hasn't changed. Yes, we're looking at, it should be starting up top here rather than in the middle, but your period overall has not changed. So the only one that we really have to find here is C. And your C, if you remember, that is where it should be starting at. So it should be starting over at x is equal to 0, and it's starting at you're going back here. I think each little tick here is pi over 6. So we're going to the left by pi over 6. That means that we have a negative value because we're moving to the left, and that would be negative pi divided by 6. That is the only difference that we have to do here. And then so simply we can just put this into our cosine equation. So we have y is equal to a, which was 2, cosine, your b was 3, with theta in there. So you would normally subtract, but you have two negatives, which would make a positive pi over 6. Close your bracket, and minus 1. So if you look, there was not a whole lot of difference between your cosine and your sine graphs. Or I guess equations, but just your big thing here that you have to change here is your C value, and that this has to be a cosine equation. So I will quickly switch over to my graphing calculator. I'll put them both in, and we should see that they're the exact same function. Alright, so here I pull out my handy dandy online graphing calculator, and here I have clearly I've plugged in both of those equations. So here you notice in the red here we have y is equal to the sine function. And we also have our y is equal to cosine, and if you notice, they both overlap. You can kind of notice that small color change as I try and highlight them, but you can tell that they are the exact same graph. They both overlap each other, so that kind of helps to prove that those equations are both equal to one another. So there's a little bit of information there. So you ladies can get started on your assignment. It is listed below on your page. If you have any questions, let me know. Happy Tuesday.